This problem is taking a look at how we calculate the future value of a lump sum of money. So the assumption would be either you've saved up some money and now you want to invest it, or you said you came into an amount of money, so someone perhaps gave it to you. So you have in your possession $700 in this case, and you want to know how much it will grow to over 3 years if the appropriate interest rate is 10%. Clear this out. So starting with the $700, at the end of 1 year, you would have the $700 back. So we always start with a 1 because you still have your original sum. And then we add to that the interest rate, so 10%. So I now have 1.1 or 1 plus 10%. So at the end of 1 year, you would have $700 times 1.1 or $770. So I've reinserted that now up here and said at the beginning of year 2 I have $770. And now once again I would end up at the end of that year with the same $770 plus an additional 10%. So I would end up with $847. So at the start of the 3rd year, same thing. I'm at $847, but I want to know how much I'll have at the end of 3 years, so I multiply that times 1.10, 1 plus the 10% interest. And my amount of money that I will have at the end of 3 years then can be calculated as $931.70. Now we can simplify this, as you can see here, with a formula by saying whatever amount you start with, you can multiply it times 1 plus the interest rate raised to however many years. So we're taking 1.10 times 700 raised to the power of 3. So 1.10 raised to the power of 3. So I can do that mathematically here. We start with $700 and we are going to multiply it times 1.10, 1 plus the interest rate of 10%, raised to the number of years I want to find out. So in this case we were working with 3 years. So we end up with, I'll make this a number so you can see the number, 1.33. So I multiply the 1.33 times $700 and I get the same $931.70. So you can see how that's much more useful than doing it this way if it's a long period of time. This is nice, you can see what's happening year by year, but let's say it was for 20 years. You don't want to have to multiply it out times 20 years. This would be easy. We would just take 1.10, raise it to the power of 20, and we'd have our factor, and multiply it times our original present value. So we call this number our compounding factor. Now we have a more simple way to do it actually in Excel because they have a PV function. And so we start off with what's the present value of the money. And in this case, the present value of the money is going to be $700. And then the number of periods that we're looking at is 3. And then we do the interest rate of 10%. And then we have a whole series of financial functions that'll help us find that future value. So on the formulas tab at the top, and this will look different in different versions of Excel, but you should be able to find the grouping for financial. And then these are all in alphabetical order. We scroll down and we find future value or FV. And if you hover over any of these, you'll get a definition of what they are. And so once we have the FV box, we insert the rate by clicking in the 10%. And you can verify it over here on the right. Number of periods we said was 3. We're going to ignore the payment box because the payment is used for annuities. That's in a different video, but this doesn't include payments. It only includes a one-time present value. And so for Excel to work, it needs to know money's going in and coming out. So we do that by using positive and negative. So if I want a positive answer, I'm going to have to insert a negative here. So I'm going to hit the negative sign, and then I'm going to hit the $700. And then I hit OK, and I get the $931.70. So those are 3 different ways you can calculate a future value of a lump sum of money.